Can you hear me? Yeah. Thank you, everybody. My name is Michele. It's Lukas.
Hey.
We work at Google here in Zurich in the information security team, and we're here to talk about the content security policy. Just very quickly, how many of you have heard of the content security policy? Of what it is, at least? Oh, awesome.
Awesome.
That's really great.
Yep.
And how many of you have tried to maybe deploy it on an actual web application? How many? Zero. Right.
I think
Okay.
there's some hands there.
Oh, okay.
Yeah.
Okay. Did you succeed? Yes. Awesome. Okay. So, yes, that was the about us. And in this talk, we'll talk about what CSP is, and we'll see like a little more in detail what's inside a policy, what a policy is. Then we'll talk about common mistakes that web admin do, and how to bypass CSP, not necessarily because of a mistake or an error by the web administrator, but also because of, I would say, inherent flaws in the content security policy as it is now. So this is, I would say, like the first, like the destructive part of the talk. But then we'll talk about a new way of doing CSP. So what we worked on in the last months is how to make CSP better, how to make it actually useful and more easily deployable and safer, more secure. So thus we talk about the future of CSP, what we see for CSP, hopefully also thanks to like your help, like the adoption, which is really crucial in this kind for this kind of mitigation, and some success stories where we deployed CSP correctly and successfully, and then there will be a Q&A. But I very warmly invite you to interrupt us at any moment if you have any question. Really like to have questions live, not just at the end, because if something is unclear, it's always better to clarify it live. Okay, so what is CSP? So the content security policy, or CSP, is a tool that you can use to lock down your web application. So it's a defense in depth mechanism against these different type of malicious injections. But it's very important to say that it's not a replacement for the usual careful validation and input validation and output encoding you should do, for example, against XSS, right, vulnerabilities, to prevent against cross-site scripting vulnerabilities. This is a defense in depth. This is basically declaring what you expect your web application to load, embed, and execute, and lock down your application to just do that. And these allow everything else. So you would mitigate risk due to an injection, because you'll never be bug-free, right? You can have an XSS, even if you are very careful. And CSP is a second line of defense. So you can have granular control over the resources that your web application can load, embed, and execute. And this is for scripts mostly, and we are mostly interested in scripts in this talk, but it also applies to styles, for example, or fonts, or several types of resources. It can be used to lock down, to reduce privilege of application. I mean, for example, HTML5 introduced the sandbox attribute for iframe that basically isolate the origin of which an iframe runs, or this allows it to execute scripts, and so on. And with CSP, it's possible to extend this sandboxing to a lot of other elements and different things. So, for example, for plugins, you can specify the exact plugin types that are allowed to execute. Just, I don't know, Flash if you want to suffer, or like something else, right? Java. And you can, for example, lock down what a form submits to, so the form action. So if there is, I don't know, like some kind of injection there, the browser would still refuse to submit a form to another unexpected location. And lastly, but not least, you can use CSP also to detect exploitation, because it is a powerful monitoring and reporting system. And basically, you can configure it to send reports to you, to like an endpoint you specify, and then you would be able to monitor them, set up alerting, so that you would get a heads up when something weird happens. So maybe you can discover that you have an XSS in place thanks to CSP. Otherwise, you wouldn't have known at all, right? And the CSP is, I would say, a work in progress. The last specification is CSP version 2, and there is a draft which is pretty close to becoming the new standard, which is CSP 3, but it's still in the works. And we are working together with MyQuest from the Chrome team and other people from Mozilla, Apple, and so on, Microsoft, to standardize some modifications, as I said before, to try to make it better. So we'll see also the shortcomings to some aspects of it, and we'll see that later. So, but what is actually CSP? CSP, Content Security Policy, is an HTTP header you can optionally add to your web application. And it's actually two HTTP headers, Content Security Policy with dashes, and this is the normal mode, which is called enforcing mode, which is the one that's actually useful for blocking what you don't want. And a report-only mode, Content Security Policy report only, which is if you are only interested in the reporting part of it. So if you want to allow everything, but you want browsers to still send you violation reports if there was a violation, which is not enforced, right? And there are many directives that try to address different problems. So for example, there is the catch-all default SRC. SRC stands for source. So for images, there is IMG SRC, child SRC deals with frames and some other things. Connect SRC deals with XHR, font SRC deals with fonts, frame ancestors. You can, for example, say, I want my application to be framed just by these origins, but not the others. You can do it with frame ancestors. Style, media, object, so on. But we'll focus in this presentation on script SRC, because this is what matters most for against cross-site scripting attacks. So how does it look like? Standard content security policy looks something like this. So in this case, you have a catch-all default SRC. So default SRC is a fallback for everything, every other resource that does not fall in a more specified, defined, let's say, bin. So for example, in this case, we define default SRC and script SRC. So scripts are governed by script SRC, and everything else is governed by default SRC. If you omit default SRC, you're just governing scripts, and everything else is free to be whatever it wants. So in this case, we are doing default SRC self. So self is a special keyword, means same origin. So it means allow every resource that is on the same origin. Script SRC is also self, but it's also relaxed. It also adds yep.com. So every script from yep.com, such as yep.com/x.js or /path/x.js, is allowed. And then you also set up report URI to CSP violation logger on the same domain. So let's say that money.example.com wants to embed a picture of a cat, and it does img src cat.png. It's an image, so the CSP looks at default source in this case, because there is no img src. It says self, said sure, cat.png is on the same origin, so it allows it. It works. So they also want to embed a script, so they do script src yep.com xjs, and as I said before, yep.com is allowed by the script src directive, so it also works. But let's say that you have XSS vulnerability on your page, and the attacker wants to inject some malicious code, like this. He breaks out, like the usual reflected XSS, right? He tries to break out, and then he does, for some reason, he wants to, I don't know, like it's a long script, it's a long payload. He wants to source it from attacker.com. This would not work because the source is not whitelisted. Attacker.com is not whitelisted, so it would block the fetching and execution of the script, and it would also send a report to you. The same if they put inline something like script alert 42. So inline scripts are not allowed by default, right? And you'll see later that in order to allow inline scripts, you have to put a directive, which is a source expression, which is called unsafe inline, and it's called unsafe for a reason. You should not do that because otherwise you basically forego all the benefits. And also in this case, it is blocked because inline scripts are not allowed, and a report is sent your way. Okay, so I'm gonna show you very, very quickly a demo, and then I'm gonna Lukas is gonna talk more. Okay, so this is a very simple web application to test this. So we can specify content security policy there, and here we have a live HTML editor. So you'll see the changes working, what gets blocked, and at the bottom you have Chrome console, right? So you'll see what gets blocked and what does not. Okay, so let's say you put IMG SRC self policy, which means I'm just interested about images, just allow images to be from the same origin. And then here I put a cat image, which is IMG SRC cat.jpg, and it works.
Where's the cat?
So the cat is playing hide and seek.
Do you have internet?
Probably don't have internet. Do I? I do have internet, but I don't, like the DNS is failing for some reason.
Yeah, it should work now, like it was the extension, right?
I think so. I really hope so. Okay, so we'll try again. This is the beauty of live demo.
Security, right?
Security. We have some extensions in our browsers. Okay, this was probably a shady DNS in this conference, so it was blocking it. Okay, so IMG SRC cat.jpg, and it works. See the cat. Okay. Thank you so much. Thank you. Like this, we tried like really hard to make this cat appear. It was not trivial. It was not trivial. Yeah. We also spent a significant amount of time, especially Lukas, I think,
Finding the picture, right?
finding the picture because it's really important. So let's say you want to load like a cat, but from let's say HTTPS, right? Because we want to be secure. evilcat.com cat.jpg. Oops, it does not work. It says down there, can you? Yes, you can.
Wow.
Refuse to load the image because it violates the content security policy, IMG SRC self. Okay? So this is like a toy example, of course. So, yes, the script, right? So at the same time, let's play a little bit with the script source. So if you put script source self, you could do something like if it existed script SRC JS x.js because it's in the same origin, it will return a 404, but as you can see, it fetches it and it executes it. But what you can't do is inject code like this, alert 1, it will not work. It will say it refused to execute inline script. So if you have an injection, this gets blocked. And here, I pass to Lukas.
Awesome. Yeah, thank you very much, Miki, for the nice introduction. So most important takeaway, CSP could be like a really, really important mitigation against cross-site scripting, right? Because if you can inject JavaScript and it does not execute, that's actually really cool. And unfortunately, XSS is still one of the biggest issues in the web world, right? Like around for many years, but still kind of unfixed. And CSP has a lot of potential, but as it's currently is, and like how the current design works, it is just mostly useless, I would say. There are some corner cases where it makes sense right now, but we have two examples here. There's one is twitter.com and the second one is gmail.com. Both content security policies are massive, right, in size. They're very long, it is super hard to come up with the whitelist entries as a developer, right? You have to go through every single page of your site and make sure that you whitelist all endpoints, otherwise you will have breakages, which is very bad. And once you have that, right, you may end up with something like that, right? It's like a colossus. And if something changes, the site will break maybe as well. So maybe it's a fair trade-off if you gain some security, right? But unfortunately, these two CSPs, which are like real CSPs, can be trivially bypassed in certain ways. And that's the case for most of the CSPs in the internet. Like we did a big study, and in total, like more than 94% of CSPs are like really trivially bypassable. And with trivially bypassable, I mean like you find one vulnerability like that in the CSP, and it's like a binary fail model, right? You find one, and the CSP can be bypassed. So we'll go into detail a bit, like what is usually in CSPs that make them bypassable. There's some trivial examples, there's some more trickier ones. In this case, the most trivial one is like unsafe inline. As we saw before, if you allow that, you can just execute inline scripts, and if an attacker injects an inline script, right, then it will just execute as well. So the CSP does not provide you any protection against unwanted script execution, which is, in our opinion, one of the most important properties that CSP can offer. So you will see many CSPs like that, script source, some whitelist or whatever, and then there's unsafe inline, and then object source none. So as we already saw before, this is very trivial to bypass, right? You just inject in some XSS vector like breakout and then do script alert, and it's like if there's no CSP in terms of prevention of script execution. Same holds true if there's no script source directive, and this is in the default source directive. Other common mistakes. If you use stuff like wildcards or URL schemes like HTTPS, HTTP, or data, an attacker could just, inject a script tag like that and source the script from whatever domain he controls, right? Or if he's too lazy to buy a domain, he could even use, maybe in the second case, data URL, right, and just ship the JavaScript right away with the payload. So the same actually holds true for object source as well, right? So this was very trivial so far, right? Now it's getting a little bit more interesting. A lot of people make mistakes when coming up with a policy. For example, this policy is insecure because they somehow restrict the script source to self, which can be okay, but they forgot to add the object source directive. Since there's no default source directive either, an attacker could just inject like a flash file and allow script access for that flash file, right? So for example, something like that, right? Fetches a flash file, the flash has JavaScript execution capabilities with like param name allows script access. You inject that, and the CSP is bypassed again. Even more or less trivial, I would say, is the keyword self itself. It might be okay to use it in some places, but if you're on a big domain with many other products, or if you're hosting like user-controlled stuff somewhere, it is usually a very bad idea to use self. For example, if you take google.com, there's like so many products, and if you like whitelist google.com, it's already game over for a reason we'll show you in a second. Also, same holds true for object source again. So this is like a made-up example, right? If you have like an upload on the same domain, you could just maybe use evilcat.jpeg.gs and source that. So, and now from the mistakes to the actual bypasses. And these bypasses from now on are also the reason why the current CSP model is kind of failing, I think, in terms of security, because almost everyone uses whitelists currently, and unfortunately, they're kind of inherently flawed. So, for example, JSONP endpoints. Does everyone know what a JSONP endpoint is? I might give a quick example. So it's basically JavaScript object notation with padding. I guess that doesn't explain it very well, right? But it's basically a URL and there's a parameter with a callback, and you specify, for example, I don't know, loaded, right, as a parameter, and then the response will have loaded and some other JavaScript object as passed as parameter to the call you specified. So it's basically JavaScript, and you can control the very first part of it, like the function. So that's very nice in the case of CSP, because you could, for example, do something like that. There's a JSONP endpoint on whitelisted.com, and there are plenty of JSONP endpoints in like CDNs and popular domains, which people usually whitelist. And you can do something like that. You have like JSONP, and then you say callback equals alert. What happens is the following. So CSP says, OK, whitelisted.com is whitelisted, so I allow it. Whitelisted.com response is alert1, semicolon u, and then some stuff, which we provided, or the attacker provided in the callback parameter. And if you source that in your page, it will look like a legit script, right? And you again can fully control the JavaScript that is executing in the origin of the bypassable.com site. Sometimes JSONP endpoints are somehow restricted because it's not so great if you can fully control the character set. So they sometimes just allow you alphanumerics and dots. Makes it harder, but there's a very interesting paper on SOM, which means like same origin method execution. And you basically can use like a couple of these to simulate like certain clicks on a page. And by that, you can represent like any user interaction with the page and also like cross-page. So it's like very advanced, but works like a charm. And it's actually really nice bypass. So we'll see a demo of that by Miki. And
Yes.
we'll continue in a second with the other stuff.
So is everything kind of clear so far? Yes? Good. OK, so as Lukas said, JSONP is really a problem. JSONP is basically present every time you see callback in a URL. Basically, that's very likely JSONP. So basically, you can control the first bytes of the response in the URL, right? So oftentimes you can't control the full, you can't inject the full alert1, but almost every time you can do something like a chain of user interaction, right? Like click, submit. You can not just click, you can also submit forms. You can like do other things. You can open frames and control them. It's pretty advanced. So in this case, I want to specify a policy, right? A policy, let's say, yeah, like this. So in this case, we have a Google Maps widget, okay, that is like over Amsterdam. See, that's a widget. Yeah. And I had to put on safe inline because I have this script block here, which is inline, right? But I don't really need it right now. So what I want to do is I just want to focus on this part. So just ignore the warnings right now. The important thing is if somebody just whitelists maps.googleapis.com because he wants to use the Maps API widget. Okay, looks secure, right? And then he uses it. But an attacker could just do this, could just inject, like it has an XSS, right? So it does something like this, and then it does script src maps.googleapis.com /maps API JS and callback.
I think you have to remove the ampersand.
Right, thank you. You don't need the ampersand here because it's the first parameter. Callback, and you can put something here. So for example, here, so the script execution is bound and locked to maps.googleapis.com, but an attacker can put alert here, and it will pop, right? So alert is a kind of toy example. It doesn't mean anything, but just wanted to prove like execution of arbitrary JavaScript. So what you can do is, for example, x.click. Now it will say in the that in this case it will say it will complain because the x doesn't exist. So if you had
Button or something.
an element in the DOM with the ID x, you would be able to click it, right? And so on. And you can include this thing every time you want. You can do it 2-3 times, right? You're not limited normally. So that's pretty bad. And we're gonna see more, I think,
A bit later, yeah.
a bit later.
Awesome. Thank you very much. So, yes. So the advice would be don't whitelist JSMP endpoints, right? Which is tricky because they are in many places, like usually where all the CDNs are, right? And usually you actually want to whitelist CDNs because you're sourcing stuff from them, right? So you cannot really sometimes get fully rid of them. And sometimes you actually need the endpoint with a JSMP, for example, if you want to use the maps widget, right? But later more. Another nice bypass is Angular libraries. If whitelisted.com is hosting some Angular library, an attacker could just include that library because it's whitelisted, right? And then execute that and use the very powerful sources expression of Angular, right? You can already do some interesting stuff with that in the scope, right? And maybe also click stuff. But you could also use like an Angular sandbox escape, right? And do like $event.view.alert and have like full JavaScript script execution again. And what is basically happening, it's not hard, right? Like whitelisted.com is still whitelisted, of course. So it can load the Angular, and then you just inject some Angular markup, and it will execute. And there's like, dozens of sandbox escapes for Angular. So the $on.curry.call will give you the window object.
Yeah.
So this, for example, works if there's like also prototype.js. These examples are taken from Q53's mini challenge site, which is a really good source to get started with reading that kind of stuff. There's like a full collection of sandbox escapes and CSP bypasses, so highly recommended to read that. It's really cool. Yeah. So the thing is, again, Angular libraries are also hosted on CDNs and this kind of stuff, and maybe you host it yourself on your same domain, right? So that's a bit unfortunate. And then, in theory, you could maybe whitelist all files explicitly, like the full path and the file name. CSP lets you do that. But first, it's really hard to get all the files listed if you have a big application. Sometimes the paths are dynamic, so you can't even do the full file listing. It also will lead to like a CSP that is like probably 2 pages long. And they keep changing, right? And it's like really not very, well, the site will probably break eventually at some point in time. But assume you can do it, right? You, for example, whitelist like totalsecure.js, which is a script you trust. And you have a second origin in your script source whitelist that has an open redirect. And so what can an attacker do, right? This one does not work. Like if he wants to inject that, whitelisted.com/JSMP callback alert, CSP will block it, right? Because it's not on totally/secure. But what he could do, he could source that file through the open redirect from the whitelisted redirect, right? And just put as a redirect URL the insecure one. And although there's a JSMP in the path and not totally/secure, it will work because CSP ignores the path after redirect. It's basically a downgraded tag, right? You downgrade the first whitelist from a full file path whitelist to just a domain. And this is very unfortunate, right? Because, yeah, it basically lowers the security of the whole thing a lot if you have any open redirect, and there usually is some, right? And this is actually, this was done on purpose to, fix another bug. I think Igor Homakov, he wrote a really cool blog post about using content security policy for evil, and he basically used CSP to extract session tokens and other stuff for redirects and brute forcing that. It's a really interesting blog post, you should read it. And they kind of fix it in the spec by, ignoring the paths after the redirect, which on the other hand lowers the security a bit, right? So this is again what happens, right? So moneyexample.com sources the script for the redirect. CSP says like, yup, site with redirect.com is whitelisted, so I allow that. Then there's a redirect. And then CSP says, yes, whitelisted.com is allowed, right? And fully ignores the path, and it will just ship back the response from the JSP, and you can execute JavaScript again and basically fully bypass the policy. So there's actually a lot of things to pay attention, right? And CSP is getting really complex. Especially, you sometimes have to ignore directives if there are other directives, right? If there's, for example, like if you have a nonce, unsafe inline gets ignored and this kind of stuff, right? It can be really confusing, and explaining all these pitfalls over and over again to developers is hard and not very efficient. So internally, we developed a small tool that just runs all the checks, right? And gives the developer, a lot of red exclamation marks usually, and tells them like, yep, that doesn't work, that doesn't work, that doesn't work. And then, they can try to avoid it. Ideally, you would give proper guidance with some documentation in the first place, but yeah. We're actually also planning to make it available publicly soon. So yeah, maybe that's useful for others as well. Yeah, so the thing is, the current view of CSP is a bit broken, right? But we still think that basically the idea is awesome, and mitigating XSS is really a great goal, right? And we think CSP has potential to maybe solve that, but not in the way it's currently used. So as I said, most people use a whitelist-based approach, which is flawed for all the reasons we saw, right? You basically cannot whitelist stuff safely, because like whitelisting a domain is like whitelisting a full city instead of a single person, right? You never know what's there, right? There's some examples, exceptions. If you like whitelist a domain and there's like only three JavaScript files that you know and they're perfectly fine, you can make it. But usually it doesn't scale very well for big applications, and it's really hard to come up with the whitelist and maintain it, right? So we thought it would be much better to use like nonces instead. Nonces are already implemented in CSP, so this is actually nothing new, but it's usually like only used like in less than 1% of the CSPs we found on the internet. So it's not very broadly used right now, for a good reason, which we will see in a second. And the advantage is, right, you could nonce the scripts on your page, we'll see it in a second how that looks like, and then first, you would not have to maintain the whitelist at all, right? So it saves you all the time to come up with the whitelist and also the maintenance and the breakages, which is awesome, and actually a huge adoption blocker. And second, stuff like JSP endpoints, you don't have to care, right? Because just the nonce scripts can execute. The problem is, very often in the modern web, you have like dynamically created scripts. So for example, you have a script that can execute because it has a nonce, right? But the script creates another script element and, for example, loads modules from somewhere else and appends it to the DOM. So this will fail because this script does not have the nonce then, right? And so this is like a very common pattern. Many libraries use that. And you could refactor all the libraries, but it's very hard. And maybe the library is not in your control, right? So maybe you can't do it at all. So we'll see how we fix that problem in a second. just a quick intro about nonces, right? So this is like a CSP policy with a nonce, and the cat image still can load because the default source is self. The script on the very left also can load because it has the same nonce as in the header, right? The nonces are set per response. Every response has a new random nonce. And this is allowed. But if you're an attacker, you don't know the nonce beforehand, right? So you can inject something like that, right? The script source attacker.com, but it would get denied because it's not in a whitelist and it doesn't have a valid nonce. And the same holds true for inline scripts. They would not be allowed to execute because there's also no correct nonce. So as an attacker, to actually inject JavaScript in a way that it gets executed, I would need to know the nonce that was set in the header in the first place, right? So this is usually not possible if the nonce is random enough and not reused. And it's a very good protection. But yeah, let's maybe take a look at the demo first and for nonces.
Yes, so is it clear why nonces are not guessable by an attacker? Because sometimes when we present this, it's not always clear why. So basically the idea is, as Lukas said, they have to be unique per each page load, right? And the browser basically checks that the nonce attribute in the script tag is equal to the nonce that is in the HTTP header. So basically an attacker cannot get the nonce without having JavaScript execution in the first place to inspect the DOM, or, well, man in the middling an HTTP connection, of course. But if you can do that, you can also inject JavaScript directly, okay? So that's the rationale from using nonces. Okay. Okay. So we give a quick example. So in this case, we call the nonce like random. Of course, it has to be truly random per each page load, right? Because reusing nonces is defeats completely the purpose of nonces because the attacker knows them, right? And let's say you do alert 1. And it does not work, right? Refuse to execute, right? Because it does not have a nonce and there is no unsafe inline, which is good. But if we add here a nonce of like random, it works. See? So this applies for both inline scripts. This is an inline script because it has like the JavaScript inside the script tags. And for, I'd say, source scripts, such as, I don't know, let's call it XJS. It will not exist, but we'll see a 404. That means the browser allows it, right? Because otherwise it would not even fetch it. So if we just do this, it will say refuse to, yes, it will first execute alert 1, and then it will say refuse to load script. See? Because it's not nonce. But if we nonce it, it will say 404. It will alert 1, and it will 404, which means it is trying to fetch it and load it. Okay, so this applies in general. This is what nonces are. And I also wanted to show really quick the problem that Lukas hinted at before, which is what it was saying here, the dynamically created scripts. So for example, a complex widget like Google Maps widgets, right? It tries to load dynamically at least 3-4 JS files that are on the same domain, right? And so here we have it. So it works, right? So we have a script with a nonce, random. Right now we don't have a content security policy, but just to let you to explain a little bit the code, you have an init map. Here specify the coordinates of Amsterdam, the zoom level. Here we have a nonce source script, as I showed before. And this is the key, and you have a callback, right? Right, so one could think, now, if I put script SOC nonce random, it will work, right? Because all scripts have nonce random, here and here, right? As I showed before. But if we do it, what happens? It does not. it says refuse to load the script, something else, which is common.js, map.js, util.js, and stats.js with a very obscure path, 25.5, which is versioning problem, probably, right? That's because this JS actually does exactly what Lukas showed before. Like, it tries to dynamically load scripts, and the dynamically loaded scripts do not have nonces. So in theory, you could refactor Maps API library to do, before doing append child, do s, like script.set attribute, nonce, and then propagate the nonce. That would work. But it's unfeasible to do it, right, at a web scale.
And this is actually also the reason why nonces did not take off so far, right? They're in the spec, they're already working by some browsers, but yeah, it doesn't really work with a lot of very popular libraries and widgets. So yeah.
Exactly. So this is a major blocker, right? It was a major blocker. That's basically why nonces are almost never used right now. They're very rarely used. Because if you have the, dynamically loaded scripts, that's a problem. And this is exactly what we focused on and what we tried to solve. And I go on, right?
Yep.
So yes, so it would be cool if you could do dynamic trust propagation somehow. So let's say somehow relax a little bit the nonce mechanism and say, well, I trust everything I have in my markup, but nothing more. So basically, I trust that a script like nonce, which is basically like saying I bless, right, could load dynamically other scripts, right? So for example, I load, and this script tries to nonce example.com bar.js, and then I say, yes, you can do it via create element script, append child, yes, you can do it. But maybe you can't do other things. You can't do document write, for example, script. You can't do inner HTML because these are APIs that are very prone to XSS and to abuse because basically it's free-form DOM manipulation. In HTML, you can put the HTML you want and so on. And with document write, well, it is kind of deprecated because it's blocking. Sometimes it's unfortunately used, so this would be a blocker also for what we call unsafe dynamic here. But it's very rarely used because document write is blocking. So a lot of module loading systems actually want it to be asynchronous. So they actually use the first thing, right? This is true for most of the web. So all the widgets we've tried worked that way. So for example, Facebook-like, a Facebook-like widget, Twitter, Google+, everything uses like create elements, so the DOM functions. So we put this in the CSP 3 specification. It's still a draft, and it might change name. So we would really like it to not call it unsafe something, because in our view, this makes CSP better. It makes it more secure, and it makes it finally useful. So deployable and simpler. So maybe it will be called something like allow dynamic in the final version. So anyway, this is a source expression you add to script SRC that allows basically scripts that are created by what is technically called known parser inserted, so they mean dynamically generated, basically the first scenario in green, they are allowed, right? If the first script is nonced. And also, the most useful feature is that if the unsafe dynamic keyword is present, it will automatically discard the whitelist, because the whitelists are inherently flawed, as we've shown before, and also we're showing it in a much more rigorous way with an academic paper we currently have pending review. We want to get rid of whitelist completely. And it's very important to be backward compatible. So we want to create a policy that works out of the box. Since CSP does not have versioning, it's very important to create a catch-all policy that works in all browsers. With graceful fallbacks for all browsers. So it's a little counterintuitive and a little dirty, but please bear with us. This is how it looks. This is generic enough. It could be used as a copy-paste in frameworks and in, I don't know, like Ruby on Rails, WordPress, things like that. And it would actually very, very likely work out of the box and give you much better security than CSP does right now with whitelists. So it works like this. Script SOC, there is a nonce, because unsafe dynamic is useless without a nonce or a hash. We didn't talk about hash, but if the resource is static, instead of a nonce, you can also hash its content and write the hash of the content. But let's focus on nonces here, because we're talking about dynamic things, so nonces. So nonce random means allow all script to execute if the correct nonce is there. Unsafe dynamic is the shiny new thing, and it's like propagate trust and discard whitelist if you browser support it. Unsafe inline is discarded in present of a nonce. So already now, like browsers that support noncing, like nonce, discard unsafe inline. But browsers that do not support noncing will ignore the nonce directive, the nonce source expression, and will honor unsafe inline, which means allow everything. So it's a no op for them. And HTTPS means allow every HTTPS script. So this is exactly what we advised against before, right? When Lukas said HTTPS is completely useless, right? Because you can do HTTPS attacker.com and exactly. So we want to allow every script in case the browser does not support unsafe dynamic and does not support nonsense. This is very rare, as we'll see in the browser compatibility session. This is basically just I think, very old browsers or, well, one browser, and you'll see which one. OK, so let's just keep this example. You remember? Script nonce, two script nonced, one inline, one sourced. It did not work with this, remember? But what if we had unsafe dynamic? It works, because we automatically propagate nonces to, or trust, if you prefer, to this script that is nonced. So this works. And you can move the little man on a canal in Amsterdam and enjoy the view. OK, so this is a policy that works for modern browsers. Well, for Chrome and Beta. But it would not work out of the box with older browsers. So this is the fallback one I was talking about. It still works, right, of course. But this works in all browsers. This works in browsers that have CSP2 support. They have partial CSP2 support. They have CSP1 support. So it works every time. It is just does not give protection because of these, right, in those cases. But we really don't care, because we don't want you to use origin sniffing and serve different policies. This is a policy that works, just works. It is backward compatible and gives always the best it can.
Yes, so if you would inject a script without a nonce here, right, in the new browser, it will still not execute despite
right.
the unsafe
yes,
inline,
absolutely.
right?
I can show that very quickly.
Because
this is not Zen.
it's only a fallback for the old browsers. Right?
So same security. It will block, OK? Or
I think we don't have much time left.
oh yes, we don't have much time left. Good. I love not having much time left. OK, good. So yes, this is exactly what I was saying. So with a new browser, everything great. It's like saying nonce unsafe dynamic. With like a CSP2 compatible browser, which could be like the current Chrome stable and Firefox and the latest Safari, so WebKit, Blink, and like the real browsers, unsafe inline gets discarded because you have a nonce. Unsafe dynamic is not understood yet because it is in a draft. So basically, what happens? It will
not drop it.
It will not drop. Yes, yes. And HTTPS will not get dropped because it's a whitelist that would just get dropped if unsafe dynamic is supported. So well, does not give much security, but when support for unsafe dynamic is introduced, it will be secure by default without having to do anything. No maintenance of whitelists. So if you change URLs, if the API changes, you don't have to worry. You are secure always. And CSP1, well, it understands unsafe inline HTTPS. Very sorry. Browser support, it's a fragmented environment. Wait for it. Yes.
Oh, it even fall off.
Oh, that's really bad.
I think you briefly saw.
Can I
it.
show?
No.
So can you guess which browser has the flames?
Links.
No. IE, exactly. That's Edge. And the other one is IE, which does not really support CSP at all. It just
I think
supports the
if
sample
you start the
touching.
animation.
Yes. Yeah, see?
Yeah.
Oh, so bad. Anyway,
Yep.
so Chrome has the best support, and Firefox, Opera, so Blink browsers, and Firefox and like Blink browsers such as Opera 2, and WebKit browsers, recent ones. So Safari, they all have non-support, so they get something. Edge does not have non-support, but it has partial CSP2 timeout. So very, very quickly, we were able to, at Google, deploy Unsafe Dynamic in a lot of services that serve millions of users and scale and cyber and big data. And questions?
Okay.
Thanks.
Can you show the flash bypass again?
The flash bypass again, sure.
In
You mean
in
in the demo
action
or?
If you have it in action, yeah, sure.
I
Yeah,
guess
I
you could just
have
copy
it.
and
I
paste
actually have
it.
an
Right?
XSS Swift on my domain, so I can show it very quickly.
It should actually work. The one
Oh
we
yeah,
have
you mean to
here.
copy paste that long one? Yeah, sure, you can do it. But I can show you also a slightly
Where is
easier
the-
one if you want, because I have it on.
Well, that's a real one, right?
That's real long, so I'll try.
real
I
one,
just don't want
yeah.
to mess it up too much, so I will do something easier for you. So let's say you just have script SOC self, okay? So that was the scenario. You forgot object SOC none, basically, right? I don't know who asked, but so let's say you have right. So you have object type application X. I don't know why this thing still exists. X shockwave flash. Something like this, probably. Data, right? Data, I think. Well, data, let's keep it like this. And then you have to do the param name, allow script access. But you can also pass it here, I think. Allow script access. Always, okay? And here you pass mickey.it.xss.swift. And oh, right. So this one has the JavaScript URL. So
Just copy and paste.
yeah, no, but
POC.
it's possible to do it without. But right now I don't. It's like with the XSS eval. But okay, yes. Let's try to copy paste that one. I knew it. Okay, so I'll try to copy paste this. So from here, okay. So this should work. Yep. That works. So basically, it was not working before because what it was trying to do is using a JavaScript URI, which is not the only way of executing JavaScript in Flash. You can do it like this, and this is very. You can do it also in a simpler way, but.
Any other questions? Or are we? I guess we're out of time, right?
Yeah.
It's time for the break. So thanks,
Yeah.
Lukas, and thanks, Michele.
Thank you very much.
Thank you. If you have
Yeah, we're still around, so if you have
Yes.
any questions.